All right, so hello and welcome. Here we are. I haven't streamed for a few hours. Just give me a moment to check the audio and pop out the chat for a few hours.
Hello.
Okay, yeah, I kind of took something of a break. Sort of. I won't go into too much detail with that. We'll just say that I took something of a break. And short break, very short. Well, not that short, but short enough. Am I good to go here? Hold on a second. I think we're good. Think I'm good. Okay, think we can be good. Take a deep breath here. Whoa. Yeah, all right, so this is gonna be number 1170. Compare strings by frequency of the smallest character. This looks like it's probably gonna be on the easier side. I've been playing a video game. I'm interested in speedrunning video games. I'm more so interested in like glitchless runs because I like the kind of logistics of it. Algorithmically, like it's a pretty interesting question. How do you optimize speedruns without glitches of games? But anyway, let the function f of s be the frequency of the lexicographically smallest character in a non-empty string. Okay, f of s is 2. Array of strings words, another array of query strings queries. For each queries of I count the number. I should actually spend more time reading. I realize one of the problems I have is I don't spend enough time reading the question and fully grasping it. And it takes me a lot longer to solve questions because I don't do that properly sometimes. Count the number of words in words such that f of queries of I is less than f of w for each w in words. Return an integer array answer where each answer of I is the answer to the ith query. So let the function f of s be the frequency of the lexicographically smallest character in a non-empty string s. Okay. For example, if s is dcce, then f of s is 2, because c is the lexicographically smallest character in the string, and there are 2 of them. Has a frequency of 2. Okay. So you're given an array of strings words and another array of query strings queries. For each query, queries of I, count the number of words in words such that f of queries of I is less than f of w for each w in words. Okay. So I have an array of words and another array of query strings queries. For each queries of I, count the number of words in words such that f of queries of I is less than f of w. So for each query, I can calculate the frequency, and then I'm looking through all of the words and their frequencies and I want to count the number of those words that have a higher frequency than the query. Okay, I'm pretty sure you could do this in nlog n time, right? I think all you have to do really is sort the words by their frequencies, which is not too hard to calculate what the frequencies are. And then for each query, sort the words by their frequency, and then for each query, calculate the frequency, and then perform a lookup on that sorted list. It's probably the easiest way to do it. There's maybe another way that's slightly more efficient, but that's probably what I'll go with. For each w in words, return an integer array answer where each answer of I is the answer to the ith query. Okay, interesting question. First query, CBD is 1, Zaz is 3. This is less than that, so we have 1 time. Okay, it's going to be also, we want to know how many words have a larger frequency than the query, right? So a probably upper bound is what I want to look when I perform the binary search. Upper bound, yeah, upper bound. Okay. All right. I think I understand. So I really just need the frequencies in an array and sort it, and I'll probably just want a simple routine, subroutine that'll calculate the frequency of a particular word. There should be, yeah, okay, 2,000 words, 2,000 queries. Should be n log n time overall. Pretty high acceptance rate, not that many submissions, but a good significant number of submissions. Yeah, this is not too bad. I think they'll go with that. Frequency, it's going to be first things first. Oh, these all lowercase letter? Yeah, okay, that makes it easier. Const standard string s. Get the frequency. It's going to be for a given s. We're going to full present of 26. Standard fill present with false. And we're going to say for const char ch in s, say present of ch minus a is true. We're going to say for 0 I is less than 26 plus I if present of I. So this will be the lexicographically smallest. Assuming these are non-empty, these strings. Yeah, they should be non-empty. So we get the smallest one that's present, and now we want the frequency as well. Actually, could do even better, just frequency. Let's say f. It's easier. If f is greater than 0, return f. Pretty straightforward. Otherwise, return -1. Okay, that'll get the frequency for each. Now I want to have int word frequencies, const int n, words.size. Let's do m. M is the number of queries, and then n is the words. Word frequencies. Say for each I, word frequencies of I is going to be frequency of words of I. And then now we're going to sort word frequencies. Right, it's just standard sort, regular sort. And then we're going to say for each const auto s in queries. Actually, I don't need this, I think. Pretty sure I don't need that. Oh no, I do want that actually. Go back. I do want that. That's gonna be I is less than m. Result size m. All right, so we're gonna get a pointer, upper bound of word frequencies of the frequency of s, and then I'm going to take from that point to the right, those will be elements that I want. So it's going to be constant, we'll say x is going to be word frequencies plus n minus pointer. Oh no, excuse me, the other way around. Pointer minus word frequencies. Say index. Convert that to an index, and this is going to be index n minus 1 minus ix plus 1 from that index to index n minus 1. And if it goes off the edge, it could be 0, right? So if the index is n, right, and this obviously, yeah, these cancel. If the index is n, if it's off the edge, then it's just 0. I think that's it. I think it's that simple. That was a lot of programming just for the idea is very straightforward. How do we do 10 minutes? Okay. Oh, yeah. I would name this the frequency array, but it actually, I named this frequency, so I could use a different name for that. Maybe I could have used a better name than F, but F works. Okay, I need to generate more, another test. I'm actually not going to generate another test. I think I could generate more tests, but I kind of just want to submit this and see if it works. I'm not going to do that. I'm just going to go for it. Okay, got it. Very good. All right, pretty fast. Let me see. Let me try. I'll submit it 4 more times, and then we'll move on to the next question. It's 1, 2, 3, 4, 5, 6, 7, 8. I want to go until like maybe 2 or 3 hours, something like that. 1, 2, 3, 4, 5, 6. Next question is remove 0 sum consecutive nodes from linked list. Looks like this is not the fastest solution. 1, 2, 3, 4. 1, 2, 3. Maybe I just need to inline this code for the frequency calculation. I don't know. Maybe if I just keep submitting it, I'll probably get 100%. It's very close to 100. I think it's probably good enough. I think it's good enough. Maybe there's a better way to do this. That's a little bit faster, but this is reasonable. I think I actually don't need. But yeah, well, 1 pass is fine. I was trying to think if there's like a better way to do this. This is reasonable. This is reasonable. There may be a slightly faster way. You could use counting sort for the word frequencies, because the frequencies can't exceed the size n. Yeah, the size of the string is relatively small, so you could use a counting sort here. That would actually improve the speed a little bit. That might be the way to get 100%, but this is good enough. All right, thank you for watching, and I'm gonna restart another question. If you like the stream, like the video, give it a like. If you like the stream, give it a. If you like the video, like it and subscribe for more. All right, take care.